So welcome everybody to the Inorganic Chemistry Laboratory. My name is Philip Mountford. Many of you won't have come across me. I'm now Head of Inorganic Chemistry, and it's my pleasure to welcome you all this afternoon. Those of you who are here for our alumni weekend, welcome back. Those of you who are keeping out of the rain, well, welcome anyway. And this is an interesting event for us. It's a joint venture between Chemistry, Torch, which you can see is the Oxford Research Centre in the Humanities, and the Compton Verney Art Gallery. And so my role really is just to welcome you here, as I say, introduce you to our very interesting lineup, to say at this point there will be, because we're in the chemistry department, drinks at the end of the afternoon session. But now I'd like to hand you over to Stephen Tuck, who's Director of Torch, and he'll handle proceedings for the rest of the afternoon.
Thank you very much. As someone who hasn't been in the chemistry laboratory since I was about 15, I'm quite excited by these thoughts here and what might be happening. So I'm the Director of Torch. It's the most convoluted acronym in Oxford. The first T is the word the. But what we are is a place where the humanities researchers can collaborate with each other, which is not a common occurrence sometimes, but also with scientists and beyond Oxford. So this is a wonderful collaboration with chemistry and the art gallery, and I think the most unexpected and unusual collaboration we've had thus far. And I'd really like to say a heartfelt thank you to those in the gallery and in chemistry for making this such an enjoyable and productive collaboration. When this was just an idea a while ago, we thought, will people really come in the summer out of term? And it was a sellout straight away. As you know, this is periodic tales, and it's really to mark the exhibition at Compton Verney. More details available at the back, and that is based on the book Periodic Tales by Hugh Aldersey-Williams, which is also available at the back if you don't have a copy already. I'd like to thank particularly the Andrew Mellon Foundation, who have funded Torch's headline programme this year, bringing together the humanities and the sciences, the Wellcome Trust, who have funded this particular series of events, and to Adrian and Jackie Beecroft and the Beecroft Trust, who are founders of the exhibition. Final thanks, and most important of all, was to our speakers. Hugh Aldersey-Williams has come all the way from Norfolk tonight, which is quite a journey on a Friday, and made the mistake of coming through Oxford rather than around Oxford to come here, which probably doubled the length of his journey from Norfolk. So thank you to Hugh for coming. The format is Hugh will speak, and then there'll be responses from Jo Hedesan and Peter Battle, a historian of science and a chemist, who will be able to tell you a little bit more about what they do than I am able to, from afraid. So over to Hugh. After that, we will then have a good time for question and discussion. One of the good things about this sort of size event is there will be good time for discussion and questions afterwards. Hugh, thank you very much.
Thank you very much, Stephen, and thank you to Torch for inviting me here. I had plenty of time in hand, and I really did want to take the scenic route, so it wasn't a total error of judgment. I, too, have not been in a chemistry lecture theatre for quite a while. I describe myself sometimes as a lapsed chemist, so I've forgotten all the kind of important stuff. It's very interesting to see that the periodic table still stops at Lawrencium, which I think it did when I was a 13-year-old at school. In fact, it doesn't, but anyway, we'll talk about that perhaps. So, as Stephen mentioned, I read this book called Periodic Tales a few years ago, and it began as many things, sort of distant memories of my school and university chemistry, but also as a set of failed exhibition proposals that I needed to find an outlet for somehow, so they came out in this book form instead. And so I'm very pleased that it's sort of managed to close the loop now and to be turning this book into an exhibition at Compton Verney. And I'd like to thank Stephen Parisian at Compton Verney and all his staff there, especially to Penny Sexton, who's done the hard part of the curating job. I've done the wish list part, and she's done the gathering up all the loans and so on. And thanks also, add my thanks to Stevens, to the Beecroft Trust, who've provided some of the funding for the exhibition. I'm going to talk about the elements as we experience them culturally without ever necessarily going into a chemistry lab. It'll be a sort of rapid journey around the periodic table, not in order of atomic number or anything like that, but in what might seem like a rather random order, but very loosely an order in which elements were discovered. And it's a journey I hope will persuade you that each and every element is potentially has a cultural role to play. And I'll illustrate this in a couple of ways. One with examples from literature where writers have understood the properties of elements and the cultural meanings that arise from them and use them in simile and metaphor. And then second, by showing artworks, many of them from the exhibition, but also some others, as some others that we weren't able to include because they are too large or too chemically dangerous, but nevertheless are worthy of note. So there were 10 elements were known in antiquity, although of course their elemental nature wasn't properly appreciated. The elements at that time were the four Aristotelian ones of earth, air, fire and water. But nonetheless, I think these materials must have been appreciated for something fundamental about their properties must have been sensed. So gold and silver, and carbon as charcoal, and sulfur occur in their native states. And then lead, tin, mercury, copper, iron and antimony are others that are relatively easily refined if they don't occur native. And so all these were there as sort of some way fundamental substances, and people sensed, as I say, that fundamental nature. An old obvious example is the Book of Revelation that contains many references, lots of torment with fire and brimstone, brimstone being the old word for sulfur. My sort of epiphany came when I was doing O-level, as it was then called, English, and we were studying The Merchant of Venice. And in The Merchant of Venice, Shakespeare's words are very carefully chosen to shed light on each element's character when you come to the scenes where Portia's suitors must choose between the gold, silver and lead caskets. And so the gold casket is inscribed with the legend, "Who chooseth me?" So sorry, I need to get some images going here. Oops.
Double click.
Yep. And now I need to go
Bottom right.
right.
Yeah, left a bit. Left a bit. Left a bit. Stop. Fire.
Okay.
Click.
Whoops. There we go. Boom. Okay. Okay. This is a very cheesy film, Merchant of Venice, as you can tell from a single image what a bad film it must have been. So the golden casket is inscribed, "Who chooseth me shall gain what many men desire." And that seems to be a straightforward appeal to avarice, to which the first suitor, the Prince of Morocco, quickly succumbs. And gold is the obvious symbol of wealth there. The silver casket says, "Who chooseth me shall get as much as he deserves." And this is slightly trickier. It's kind of an invitation to a trade. There's a sort of equation there, as much as he deserves, and something's being traded for something else. And that's an allusion to gold, to silver's role as currency. And Aragon, who's the next suitor in line, likes the idea of some kind of transaction, even though he's not sure what he's going to get. And then the inscription on the lead casket reads, "Who chooseth me must give and hazard all he hath." And this is the fatalist's choice, echoing lead's historic role in determining our fate. The Romans used lead dice, for example, because lead falls decisively. And the worthy suitor Bassanio rationalizes the choice differently from the rich suitors who've gone before him, and he says, in a world still deceived with ornament, he rejects both the gold and silver and, of course, chooses the lead. And the three suitors have been guided in their choice by their perceptions of the respective metal's worth, although it's notable that Portia is scrupulous in never assigning value to any of the metals. And so gold is predictably identified as the most desirable, silver as pure and virginal because of its whiteness, as well as being the stuff of common coin. And the three have called lead dull and base and meagre in turn, but only Bassanio is not put off by its ordinariness. I said lead is associated with fate and fatalism and with death and the acceptance of death. This is still true, in fact, and there's a custom in Germany and parts of the Czech Republic, sort of Bohemia, for Bleigießen, which means lead pouring, and you melt some lead and you pour it into a glass and it water, and it sets in a fancy shape, and from the fancy shape you deduce your fortune. It's a sort of Central European equivalent of reading tea leaves. So here's Angela Merkel getting the result she didn't want in an example of Bleigießen. Coming back to silver, silver's the whitest of all the metals, the cool moon to the hot sun of gold. It has ancient links to purity and virginity and the feminine, as well as more recent associations of social class. And both meanings come into play in more recent works, such as The Great Gatsby, for example, where Daisy Buchanan, the nice girl that Gatsby knows of old, is idolised, gleaming like silver, safe and proud above the hot struggles of the poor. And Cornelia Parker also taps these associations of silver in her work 30 Pieces, which is one of the pieces in the exhibition. And the title refers to the biblical quantity of silver for which Judas betrayed Jesus, of course, but it also references the elements by the artist using domestic tableware. She's referring to the associations of that element with social status, and by squashing them, she's perhaps making a comment on what she thinks of that social status. Tin is another element with a lot of cultural baggage. Unlike silver and gold, it's cheap, and it's strong enough, though, to make useful items, yet soft enough that they may be formed easily by simple hammering, and you don't need great artisanal skill to do it. And it's easily melted, unlike iron or copper, for example, much lower temperature. And so tin is our sort of metallic shorthand for cheap and sometimes nasty. Henry Ford's accessible car was the Tin Lizzie. Low-value coinage is referred to as tin, and so on. And Hans Christian Andersen wrote a fairy tale called The Steadfast Tin Soldier, which ends tragically with the soldiers being consumed in a fire, along with the paper ballerina that he loves. And raking the ashes later, a maid finds that the soldier has melted into the shape of a heart. Tin is disposable, and yet also, like all the elements, of course, indestructible. So it's easily cast, but also easily recast. And there's a significant hint of this early on in the story, where the box of toy soldiers is opened, and it's a box of 24 toy soldiers, and 23 of them are complete, but the 24th is missing part of the leg because the tin ran out. The ease of working tin made it a commonplace metal. Bronze was reserved for ceremonial weapons, for example, and gold and silver for church and court. Ironware required the services of a blacksmith, but anyone can work a piece of tin into something useful. And so it was used to make sort of all kinds of peasant artifacts. The phrase tin ear reminds us that tin was also moulded to follow the shape of the body to form prosthetic parts for people whose ears had dropped off from syphilis or something in time gone by. This is our tin work in the exhibition by Eduardo Paolozzi. It's a bust, it's called Mr. Crookshank, strangely, and it shares the independent group of artists' preoccupation with materials from the cheap end of consumer culture. It's based on the model of a human head used for research in the treatment of brain tumours, rather strangely, but it therefore has this kind of echo of this traditional use of tin to be shaped to the parts of the body, to the head and so on. Our exhibition includes works that use all of these ancient elements except antimony. I've got a couple of examples that we weren't able to get in the show. I haven't really got time to talk about this in great detail. This is by Alexander Calder. It's called Mercury Fountain. And it is what it says, and the mercury goes up to the top pan there and trickles down through these other ones and back into this vast pool of mercury at the bottom. Very nasty, poisonous thing, but very beautiful as well. And it was made as a memorial to Republican fighters in the Spanish Civil War. Mercury being mined abundantly in parts of Spain and having a great cultural tradition in Spain. Somewhat similar in a sense, Anthony Gormley's Angel of the North uses iron to link with the industrial past of the Northeast, and shipbuilding in particular, and also a habitual link in much of Gormley's work between iron and the human body and our blood, which contains iron, and the colour of the blood being the colour of the rust, and so on. We have the smaller work there, which is called Fuse. So my point is that all the elements are on a journey into our culture, helped by the uses to which they're put in industry and craft, and they acquire meanings to which writers and artists respond. All artworks are made of elements, of course. What we've tried to do is to find works where the artists have recognised the sort of particular physical and sometimes chemical properties of an element and have engaged with that in ways that sort of seem to extend its cultural existence. So I can't really expect you to believe this thesis, though, without kind of moving on to some of the newer elements. So I want to talk briefly about three of those, I think. One's chromium, which was discovered in 1798, but only in the 1930s or so it became widely seen as chrome plate, and it became the kind of affordable gloss of the new consumer society. And then as the consumer promise began to fade and began to seem as thin as this layer of plate, chrome still somehow stayed on as a slightly naff indicator of our ambivalence and disaffection about consumerism. So in Vladimir Nabokov's Lolita, for example, 1955, he describes Lolita's mother's depressingly bright kitchen with its chrome glitter and cute breakfast nook. And then in 1997, in Underworld, Don DeLillo writes about lonely chrome America. So here you can see how the attitude towards chromium in consumerism is changing. Richard Hamilton's paintings, done around the same time as Lolita came out, some of these incorporate, they represent some of these shiny chrome-plated consumer objects, and he often uses bits of metal foil in the works themselves. And so they pick up on this superficial glamour of the chrome-plated world. We don't have Hamilton in our exhibition, but we do have some works by Maria Lalich, an artist who's used the contrast between shiny metals and their various coloured pigments made from their compounds. One of them being chromium, the greener one there, the other one's related to cobalt. Sodium was discovered more recently, still in 1807, and it's again became familiar in about the 1930s through sodium streetlights. At that time, poet John Betjeman called sodium like yellow vomit spewed out from concrete gallows. So he didn't like it much, even though it was the light of the metro land that he did love. There's a bit of ambient sodium light. What's interesting is that writers very quickly sort of reached a consensus as to what sodium meant, and it seems to sort of convey a general sort of urban dystopia. Got a couple of examples here. So in Tom Wolfe's Bonfire of the Vanities, Sherman McCoy, the New York City bond trader, early on finds himself out of his comfort zone while out walking his dog in the rain. He's on Park Avenue, but dangerously close to 96th Street, the crossover into Harlem, when he senses a black youth walking towards him. And he writes, Wolfe writes, the feeble yellow of the sodium vapour streetlight reflected for an instant on his face as he checked Sherman out. And that's an early warning, if you like, of the much greater nighttime collision to come in that book. And then J.M. Coetzee's novel Age of Iron, set in apartheid-era South Africa. Coetzee's narrator, Mrs. Curran, is a retired professor who's dying of cancer, and she's being driven with her maid into one of the townships. And the car splashes through pools on the uneven road under the sick orange of the streetlights. And the light is a metaphor both for her cancer and for the cancer that's destroying the country there. Many other examples I've got from Joseph O'Neill, from Jean-Paul Sartre, J.G. Ballard, Will Self, Anthony Burgess, and so on, all kind of using sodium to convey the same sense. So on every continent, sodium is now the colour of the city at night and the means by which we know that element. And there's a very good sort of quick explanation for this. I hope this is a spectrum of sodium at the bottom, Na is sodium, and its colour is entirely that shade of yellow. There are no other colours coming out of that light, which means that it sort of deadens the colour of everything that it shines on. A final literary example unexpectedly brings together both sodium and tin. And this is from Rose Tremaine's recent novel, The Road Home. And it describes the experience of Lev, an Eastern European migrant who travels to Britain for work. And Rose Tremaine opposes the two elements in her narrative. Lev's bus crosses, this book's become newly timely, Lev's bus crosses into Austria during the night and stops for petrol under a sodium sky. And that becomes a recurrent image. But back in Poland, his grandmother supports the family by making jewellery out of tin. And here sodium signifies the modern technological sophistication, the urban West, and tin speaks of home in the rural East, of simple crafts. Neon is, as its name suggests, an even newer element, discovered 1898, and that's again found its cultural place in many of the same places as sodium, of course, but with a slightly different set of associations. In Lolita, for example, again, and American Road movies, it sort of is used to, it holds a kind of empty promise. Neons, of course, signage is used for urgent messages, for selling sex and drink and kebabs. And artists have noticed this and made merry with this self-importance and urgency. This is a work by an artist called Tim Etchells. We haven't got this in the show, but we have got another work that he's making for us. and the slogan that he's working to this time is "Something common in the universe, but rare on Earth," which is a description of neon itself. And meanwhile, Fiona Banner has noticed how neon signs in that desperate urgency of theirs tend to shout in capital letters and leave out linguistic nuances like punctuation. So she's just sort of reinstated the missing bits of the language. We've got a work called brackets in our exhibition, and these kind of shapes somehow begin to look like relics of a civilization, just like leftover tools or something. Uranium has become the element we associate with nuclear power and the atomic bomb, of course. But before that, it was known that a little bit of uranium could be used to make glass fluoresce with this ghostly green light. And the artist Kate Williams has brought together both of these qualities to make these glass castings of nuclear power stations. And that's Sizewell and Dounreay there, and Springfield is the one on the top. So real and fictional nuclear power stations. And I was going to show you my homeopathic plutonium, but if anyone wants to have an application, in fact, of homeopathic plutonium, I can administer it afterwards, but I haven't got it up here in front of me. So just to summarise, in these works, the elements are implicitly acknowledged as a kind of prima materia, the old alchemists' sort of generic starting material, which was sometimes based metal, which was taken to be lead very often, but also linked to other materials of the humblest kind, such as clay and body fluids and so on. And they obviously comprise some of the very oldest art materials. The white of chalk, which calcium gives chalk its whiteness, and also marble and alabaster and many other artists' materials. That sort of iconic whiteness is due to calcium. These are two works by Cornelia Parker again. The one on the left are fragments that have fallen from Beachy Head, a work called Edge of England, and the other work is called Inhaled Cliffs, and it's bed linen starched with chalk from the cliffs of Dover. Bed linen for lying back and thinking of England, maybe. And then at the opposite extreme, we have black. Carbon is probably the very oldest material used for making artistic marks, and these works refer to our use of it both in writing and lettering, work by Lucy Scare called Black Alphabet on the left, and in design, these sort of pure forms by the artist David Nash. And other elements provide other pigments, of course, ochre, iron, as we've seen, and verdigris of copper, these sort of primal colours, but also very humble, almost waste materials, sometimes abject materials that provide a link to the kinds of materials used by the arte povera artists. So we have obviously elements like gold and platinum at the sort of rich end of the extreme, but the artist's use of the element goes all the way down to the opposite extreme as well. The work on the left here by Gilberto Zorio, he was one of the artists of the arte povera movement. And the work on the right is by Roger Hirons in the exhibition, which are some car engines that have been encrusted with copper sulfate. So we see how artists run the same gamut as the alchemists of old. Alchemists were trying to go from base materials to gold. Artists occupy stages all along that journey, as we'll find in the exhibition. I just want to end with one slide from, these are several works by Cornelia Parker again, who is the artist, I think, who's probably used more of the elements in ways that tap their cultural history than anyone else. But it's important to realise she's not using them because they're on the periodic table. She's using them because they have stories that spring from their particular elemental properties. The works are, that's a hammered wedding ring hammered out flat. The top right is called Explosion Drawing, which has 3 layers of sulphur, the yellow, charcoal, the black, and saltpeter white, which you can't really see there, the 3 ingredients, and gunpowder held permanently apart so they can't explode. There's always that sort of sense of an impending explosion there. The bottom left work is one of a series called Stolen Thunder, where she's rubbed the tarnish off various celebrated or infamous objects. And so it makes us think about the sort of value of celebrity and notoriety there. And the final work is one of a series called Bullet Drawings, where the artist has taken lead, all the lead from a bullet, and drawn it out into a wire, and then used the wire to create these patterns. This one, in fact, looks like a kind of net that has itself caught a bullet on the fly. So, perhaps this would be a question for sort of afterwards, but there are newer elements or more obscure elements that are also kind of becoming culturally owned, and we might want to kind of speculate as to what's next to be recognised. There are many works I haven't been able to show that we'll have in the exhibition. I hope you'll come and see the exhibition up the road at Compton Verney. Joseph Boyce's take on sulphur, Thomas Heatherwick's aluminium, the works by Mark Quinn and John Newling, Tanya Kovacs, and Ken and Julie Yonatani, and many others. And often we've put historic artifacts alongside some of these newer artworks to show the continuity and the ways in which a given element has been used at different times. So do please come and visit. Thank you.
Well, first of all, I'm glad Hugh talked about alchemy, because this is what I'm going to respond on. This is actually my specialty. I'm a historian of alchemy, and I'm working as a Wellcome Trust postdoctoral researcher here in the history faculty on the topic of universal medicine in 17th century alchemy. Thanks again for inviting me, and basically what I've decided to talk on for a brief 10 minutes is the element of gold. Now, in popular culture, alchemy is usually defined as the art of making gold. It is undeniable that throughout its history, alchemy had a particular relationship with the element of gold. However, making gold was one of the many goals of the art, and by no means the most valued. When I was invited to make this brief presentation, it seemed fitting that I should structure it around the element of gold, since it offered me the opportunity of discussing alchemy's peculiar and not always straightforward relationship with this metal. As Hugh Aldersey-Williams has shown, throughout history, gold has held special attractions for many civilizations. Although the true significance of gold for ancient peoples is hard to fathom, we can speculate that it was a combination of qualities that made it so praiseworthy. First, its shininess. In fact, the fact that the shininess was the chief trait that they perceived in gold is proven by the fact that the Latin name for gold, aurum, originated from an Indo-European word meaning glow. Moreover, the ancients saw that gold not only had an uncanny ability to reflect the rays of the sun, but also had a similar color with that of the astral body. A natural reverence for the sun might have led to a similar appreciation for gold. But there are other elements to gold that make it very valuable. Gold is scarce. Even today, the Earth's entire quantity of excavated gold is no more than a cube 20 meters across, while the Earth's crust contains an estimated 0.000005% of gold, as compared to, let's say, iron at 5%. Moreover, gold has two unusual and paradoxical qualities. It is soft and easily shaped, while being incredibly resilient not only to fire, but also to ordinary solvents. Hence, gold could easily be fashioned into objects that would be associated with the richest and most powerful individuals in a society, as indeed it was. Spectacular ornaments were made out of gold, none more so than those found in the Egyptian pharaohs' tombs. Manipulating such a temperamental metal as gold required metallurgical artisans who would work with it. Alchemy would have grown out of the superior art of certain goldsmiths who knew and used the secret possessed by the metal. Ancient texts show that some of these turned to making imitations of gold. The idea of making real gold must have evolved out of these imitative practices. Although there is, of course, a major leap of faith from saying I can make a metal look like gold to saying I can make actual gold. It seems that the idea of transmuting metals into gold was mixed in with a belief in the sacred and secret nature of this knowledge, as proven by the earliest works on this subject. But why try to make gold at all? The trivial answer, of course, is to procure wealth. But as it turns out, most alchemical writers decry the idea of making gold to become rich. They saw something more to gold than this, but in order to understand them, we must make a brief incursion in the alchemical theory of metal formation. Thus, all alchemists consider gold to be produced in the bowels of the earth through a process of maturation of inferior metals. In essence, this meant that all metals could potentially become gold if the natural process was replicated in the laboratory. This further implied that an alchemist who were to master this secret technique would be a sage initiated in the deepest secrets of nature. Thus, in many ways, gold-making alchemists were primarily seeking a non-trivial knowledge that would have lifted them above their contemporaries. To be sure, it was not just gold makers that held spiritual views of gold. I have already pointed out that gold was often associated with the sun. Many alchemists also thought that there was a correspondence between gold and the human heart. Consequently, gold could be used to obtain an all-powerful panacea that could restore health and even prolong life. This medical goal of alchemy did not require transmutation. What it needed was a deep knowledge of metals, such as only philosophers would have. Now, the relationship between alchemy and gold is illustrated by the alchemical writings of the Renaissance period, when the non-trivial views of gold were not only rendered most explicit, but also elaborated on. Due to the brevity of time, I will focus on only one brief treatise by the German alchemist Michael Mayer, 1568 to 1622, here portrayed. Mayer is now best known for one of the most impressive alchemical works of all time, which is Atalanta Fugiens of 1617, which uniquely combined poetry, images, and music to illustrate the quest for the philosopher's stone. Mayer wrote many other treatises, including the one that I will briefly discuss, which is the Circulo Fisico Quadrato, or On the Squaring of the Physical Circle. So, in this work, Mayer deems gold the symbol of perfection in the sublunary world. He associates it with the sun in the upper sphere, not only because gold resembles the sun through its shine and color, but most importantly because it contains an inner heat ordinary people are not aware of. He considers it the purest and most homogeneous metal and the only thing on earth that is incorruptible and close to eternity. Everything else is in a flux of inconstancy, growing or diminishing, but gold alone remains immutable. Fire makes gold malleable but does not destroy it. Acids corrode it but do not consume it. Indeed, Meyer contends God bestowed gold upon men as a reminder of their own eternal afterlife. The incorruptibility and immutability of gold render it eminently capable of preserving and restoring human health, he thinks. Meyer postulates that gold has an occult relationship with the human body, and most specifically, the heart. This is because gold, like the human blood, contains a humid heat in its innermost core. Meyer argues that gold can be turned into an universal medicine if rendered potable. He was not, of course, the only one to make this argument. Indeed, this was the era of potable gold, when physicians and empirics were trying to extract the virtues of gold into a drinkable concoction. Yet Meyer dismissed any attempts at obtaining a medicine out of gold which did not involve alchemical manipulation. This is because gold in its solid form is not compatible with the human body, as the stomach cannot digest it. Consequently, Meyer maintains, gold needs to be destroyed completely in order to extract its medical essence, something only alchemists can know how to do. So Meyer's panegyric to gold leads him to condemn the venality and avarice of his era, decrying those that desire gold as wealth. By extension, he criticized those alchemists who sought to make gold as being greedy and unwise. In his view, the true goals of the alchemical pursuit were very different: to obtain the universal medicine that could cure human illness, and to gain divine knowledge and strengthen one's faith in God. It is true that gold played an important role in the acquisition of these goals, but it could not be a name in itself. It is not that Meyer did not believe in transmutation, almost everyone did at the time, but for him gold making was less important than other goals of alchemy. So I will summarize this brief intervention by saying that the element of gold held a special significance to alchemists, but this went beyond that of a means of obtaining wealth. It is doubtless that some pursued the art of alchemy in the attempt of getting rich, but as it was often pointed out in the era, the practice of the art was very expensive and more likely to ruin one's fortunes than to build them. The irony of alchemical practice is that it usually involved destroying gold rather than making it. As I have pointed out in Meyer's treatise, his focus is not on making gold, but on destroying it so thoroughly as to never be reconstructed again. This position, which was common amongst early modern alchemists, points to the fact that the esteem of gold went beyond the ordinary one and hid uncommon beliefs in its intrinsic power. Thank you.
Hello, I'm Peter Battle. I'm one of the lecturers in this lab. And so I'm going to talk about some of the ways in which I see art as a chemist. And the last time I lectured here, I was talking about lithium batteries and oxide fuel cells. So you have no idea how far out of my comfort zone I'm feeling at the moment. I'm an inorganic chemist, and I guess one thing that sort of distinguishes me from the approach of the two previous speakers is I'm more interested in compounds than I am in elements. Everybody so far has talked about the elements, and the elements are very important. This periodic table up here is my toolbox, and I work basically on the borders of chemistry and physics, and I try and make new magnets, and I usually take a bit of oxygen and something from in the middle here and something from the left hand side, and try and combine them in a way that's going to give me a new magnet. And the elements are important to me, because if I take ruthenium, I'm going to get a different result to if I take cobalt, for example. So the difference between the elements is very important to me. But to me, the elements really come into their own when I combine them to form compounds. And so what I want to do today, and each element basically brings something different to the party. That's the point. What I want to do today is just talk about the way chemists are perceived by artists. I want to say something about the way art is perceived by chemistry. And then I want to finish, if there's time, by moving actually away from the periodic table and talking about something that is present in both art and chemistry and is very important, and that's symmetry. So, if we start, okay, so this is one of the paintings that's in the exhibition at Compton Verney. It's Douglas's view of what alchemists are like. And if you look at this, it seems that beards and round-bottom flasks are the centre of the activity. Now, actually, I mean, as I say, I've never given a lecture like this before in my life, and I was asked to do it by Susan Davis, who's the chemistry alumni officer and is responsible for putting all this afternoon together from the point of view of the chemistry department. And I thought, well, what can I do? And I thought, well, the least I can do is show my holiday snaps. In the late 19th century, the Viennese decided to build what is essentially a high-class inner ring road in Vienna with very large grand houses and palaces. And they got the local run-of-the-mill artists like Gustav Klimt to come in and decorate. And one of these rich guys brought in Macart, and he painted an allegory of chemistry. I don't get it. To me, it's a cherub wearing nothing but a sporran, looking at a round-bottom flat. He's not wearing safety glasses, he's not wearing a lab coat, but that was Macart's view of an allegory of chemistry. Actually, I mean, the sad thing was that it was next to a painting called An Allegory of Science, as if alchemy and chemistry aren't part of science, and the people in the painting of science actually had beards and compasses and dividers and looked far more serious, so not a good start. There are many occasions when chemistry and art come together. I mean, the way most people come to chemistry is at secondary school, and the things that fascinate them are the smells, the bangs, and the colours. And as you get older, you realise that the smells and the bangs are just plain dangerous, and what you're left with is the colour. So, I mean, there's clearly a lot of people are turned on by the beautiful colours of the compounds we make. I mean, I still get a kick out of seeing a nice blue compound where one of my students makes it. And funnily enough, there is a company in Vienna called Wolfram, which is an alternative name for the element tungsten. That's where the symbol W comes from tungsten. Wolfram is a company in Austria. Farben Zauberer, according to Google Translate, is a colour wizard. And what this basically says, we mix each colour with the computer exactly as you want, I think. So, I mean, this is very light-hearted. It's just a pure coincidence that somebody called Wolfram, the name of one of the elements, is mixing colours together, which is one of the ways people get into chemistry in the first place. More seriously, this is a painting by Picasso, and you have the blue in the painting. Picasso would have known as cobalt blue. He would have called the white bit pigment lead white, and the yellow pigment cadmium yellow. Now, to me, they're cadmium sulfide, lead carbonate, and cobalt aluminate. Chemists have that sort of mind where they want to know what it really is. And I've spent many happy hours standing where I'm standing now, explaining to an audience rather less awake than you are why cobalt is blue. Okay, I mean, the chemists get down to the nitty-gritty. It's the electrons. It's the electrons in the atom changing their energy, giving rise to the colour. And that's understanding that is the sort of thing that turns chemists on. Whoops, Hugh showed this one, Fuse by Anthony Gormley, and he explained that it's made of iron. This is one of the exhibits in the exhibition at Compton Verney, and if you like, it represents iron. And Hugh explained that it's made of iron because blood contains iron, and so this is a sort of representation of the human. I'm sorry, that's a paraphrase. I mean, you put it far more elegantly than I did. But I don't see it that way. I mean, to me, this is a representation of a human body. It has some really interesting sort of facets and faces and the way the body is developed. But I don't see this as blood. I mean, that might be because I know that iron and the iron oxide, which it might rust to, are chemically nothing like the chemical that contains iron in blood. Maybe I know too much. Sorry, that sounds horribly arrogant. To me, I don't get the blood link, and I don't get the. And so to me, it's a nice sculpture that doesn't really say anything about iron, apart from the fact that it's made of iron. On the other hand, there's the Atomium in Brussels, and this was built for the 1958 World Fair in Brussels. It's basically a cube standing on one point, and there's a sphere on every corner and another sphere in the middle. And that's a representation of the crystal structure of iron metal. If you take those cubes and put them next to each other to fill space, it's a model of a very large lump of iron. It's the structural building block of iron. And I thought this was great. I saw this when I was 27 years old, and you can go in it and you can walk around these spheres and you can walk along these things which to me are chemical bonds. And so I'm walking from one iron atom to another thinking, gosh, I'm an electron in a chemical bond, this is really neat. And that really was special to me. I mean, maybe I'm just nerdy. I'm a northern chemist, in fact, you ought to know that. So to me, this really was iron, and it meant something. If you read the Atomium website, as I did this morning, it tells you why this was built. It symbolised the democratic will to maintain peace among all the nations, faith in progress, both technical and scientific, and finally, an optimistic vision of the future of a modern, new, super-technological world for a better life for mankind. No, it's not. It's a body-centred cube. So, I mean, I'm sure that's why it was built. I'm sure that's what the artist had in mind. But to me, that's not what it says. What I would like you to notice is if you sort of would put a piece of paper perpendicular to the screen down there, then the right-hand side reflects the left-hand side. It's almost as if there's a mirror down that crystal structure. That's Buttermere. I told you I was going to show you my holiday snaps. And you can see that the Lake Buttermere acts as a mirror and reflects the hill on the far bank. And my point is, that I want to make, is that there are mirrors in nature, as in Buttermere. There are mirrors in nature, as in crystal structures. And this is symmetry, these reflections. Let's go on a bit. This is a compound. I say we take the elements, that's our toolkit, we put them together, we build up crystal structures. This one contains lanthanum, lithium, rhodium and oxygen in a fairly obscure combination. If you draw a horizontal line across there, it's like a mirror. The top half reflects the bottom half. There's symmetry in this crystal structure, in the same way that there was symmetry in the reflection of a hill in the Lake District. And if you just take those yellow and grey atoms and throw away everything else and draw them out, you get that. And that's a highly symmetrical pattern. And I mean, I wouldn't actually mind having that on my bedroom wall as a work of art. I mean, I think that's nice. And I put on the bottom there a quote from Blake, the Tiger, burning bright, a comment on the symmetry of the picture. This is salt. This is sodium chloride. This is the chemical that you have on your dinner table most nights, unless you're a healthy eater. And if you think of the blue atoms as being sodium and the green circles as being chlorine, you can see, first of all, it's periodic. The chlorine atoms occur with a regular spacing. The blue atoms occur with a regular spacing, and the blue atoms sit on top of the green atoms. So you have two components, each with a regular spacing, with a relationship between them, one sitting on top of the other. And again, you can see that you can put a line there, or a line there, or even a line across the diagonal, and you've got a mirror. And everything in chemistry is very symmetrical. And then you go to Sweetheart Abbey in the Couvragère, whatever it's Dumfries and Galway, it's called there. And you can see in this the architecture of this building, there's a mirror plane down there. If you look at these pillars, they're regularly spaced. So all the features that are present in the crystal structure of the compounds of the elements in the periodic table are present in architectural design. Sweetheart Abbey, incidentally, was built by the same person who built Balliol College. Well, you had to get one right. If you go to Jedburgh Abbey, a bit further to the east, you see you have these large arches, periodically arranged, and then on top you have the small arches. Two components, each regularly spaced, sitting on top of each other, just like the atoms in sodium chloride. So I think that's my last slide. Yep. And what I've tried to do is say that I think there are some ways in which, first of all, I think the elements and the way they combine is very important in art, as well as just the elements themselves. And I've tried to explain how I see things differently from Hugh. I worry about where the colours are coming from. I mean, I often think, people talk about Picasso's blue period. I mean, wouldn't it have been better for chemistry if they called it Picasso's cobalt period? And what I've also tried to do is just introduce the idea of symmetry, which is so important in chemistry and is present in art and architecture as well. Okay. I think that concludes.